we're going to just establish a trigonometric identity. So the first thing we need to know on this one, because sine squared plus cosine squared of theta equals 1, I can rewrite cosine squared equals 1 minus sine squared. So I'm going to rewrite this as cosine squared. And on the denominator, what I'm going to do is I'm going to go ahead and pull out a negative and write this as 1 minus cosine squared of theta. Because if you distribute that out, you would get this here is negative 1 plus cosine squared of theta. And then when you pull out a negative, you get this. And the reason we want to do this part is because then we can get that this equals sine squared. Because if you subtract, if you take this and subtract cosine squared from both sides, you get this here. So this is going to be sine squared. So basically we get negative cosine squared of theta over sine squared of theta, which is going to equal negative cotan squared of theta. All right, next one is this one. This one, you just need to know, oh, these are both squared, that this is your form of a plus b squared plus a minus b squared. And we know that this equals a squared plus 2ab plus b squared. And this one's going to be a squared minus 2ab plus b squared. And that's what I'm going to do. So my a is sine and my b is cosine. So I'm going to get sine squared plus 2 sine cosine plus cosine squared of theta. And this one's going to be plus sine squared, I'm going to run out of room, minus 2 sine theta cosine theta plus cosine squared of theta. Now what happens is this is minus here, so these two will cancel out. And basically we have sine squared plus cosine squared. That's going to equal 1. That's for those two. Then we have another one, sine squared plus cosine squared, and that equals 1. So 1 plus 1 equals 2. And the next one is this one. I'm going to use as my common denominator as secant of theta plus tan of theta times secant of theta minus tan of theta. So that's my common denominator. I just cross up here. I'm going to write it out. So this is going to be secant of theta minus tan of theta plus secant of theta plus tan of theta. So for our numerator, the tans cancel out, and we get 2 secant. For the denominator, this is your a plus b, this is your a minus b, and that equals a squared minus b squared. So that's just going to be secant squared minus tan squared. Now, the denominator just equals 1, mainly because of your Pythagorean identity that 1 plus tan squared equals secant squared. And you're just subtracting tan from both sides. So that equals 1. So our answer is 2 secant of theta. The next one is a plus b times a minus b, which equals a squared minus b squared. So that's going to be cotan squared minus cosecant squared. And we know that equals 1. The reason we know that is because our identity is cotan squared of theta equals 1 plus cosecant squared of theta. And again, you're just adding the cosecant squared of theta to both sides. And if that cancels, then you get that. So this whole thing, here just equals 1. And the next one, and the last one. So I'm going to factor this. This is your a squared minus b squared. So we're going to get cosine theta minus sine theta times cosine of theta. You know what? I'm going to let me do something else first. Just thought of something. Let's just leave the numerator there and see if I can do something else. Cosine squared of theta minus sine squared of theta. And I'm going to factor out my quartic. That means the degree is 4. And use that, my a squared minus b squared. So that's really going to be sine squared minus cosine squared. And then it'll be sine squared plus cosine squared of theta. Now, we already know that sine squared plus cosine is just 1, so I can just leave that as 1. And now I'm going to go ahead and factor both of these. So we get cosine squared of theta. Well, actually, what I can do is I can write the numerator. In the denominator, just pull out a negative. And then you would get cosine squared of theta minus sine squared of theta. And all of that's going to equal 1. Now, just remember let's go over here. Anytime you have something like this, a plus b over a minus b, b minus a, you can rewrite, you can multiply the numerator and the denominator by -1. B minus a. So that leaves a negative in the numerator. But if I distribute this, I'm going to get negative b plus a, which is the same as a minus b. And I think this was supposed to be minus. So this should have been minus. Sorry. I'm trying to go too fast. Okay. So then what we get, once we do that, we get a minus b. And so that cancels out. So anytime you see something like this, so if I have a 2 minus 3 over a 3 minus 2, that's always going to equal -1. Any numbers you put in there. We could have also did like we did the previous, a squared minus b squared over b squared minus a squared. That's going to equal -1 for the same reason we did that. Okay, thank you. Have a nice day. Bye-bye.